Hi, Math 2 Enhanced. This is page 7 of our packet, and we're going to discuss the difference between factoring and solving. So we've been factoring, and in this case, we did our A times C at the top and our B at the bottom, and we would find our numbers, multiply to the number at the top, and add to the number on the bottom. And in this case, my A was 1, so I could use the shortcut, and my side numbers are just the numbers that go in my parentheses. This is the factored form of x squared minus x minus 20. This is different than when we solve. When we solve, we have to end up by finding what our x is equal to. So if I was solving by factoring, I would keep going after I add my x minus 5 and x plus 4. Notice now I've got an equal sign, and it's equal to 0. It's an equation I want to solve. So if the product, that means times, the product of x minus 5 times x plus 4 is 0, then either x minus 5 must be 0, or x plus 4 must be 0 by the zero product property. So x would be 5, or x is negative 4. These are my two x-intercepts. It's where the graph crosses the x-axis. They're my roots. They're my solutions to my equation. So let's take a look at some more examples of solving a quadratic equation. There's 4 methods we're going to discuss today. The first one I'd like to discuss is taking the square root of both sides. This method only works when you have only an x squared term or a binomial squared term. So no x term. In other words, if you look at the problem that's given, the example, there's no x term. There's only an x squared term. That's it. So we are going to isolate the x squared term, and then we're going to take the square root of both sides. So I'm solving this like an equation. The first thing I'm going to do is move the 15 by adding 15 to both sides. I get 4x squared equals 16. I want to continue isolating the x squared divided by 4. And I finally get x squared equals 4. Once I've isolated my x squared, I can now take the square root of both sides. When I do that, when I'm doing quadratics, remember to have plus minus the square root, because in this problem, we are looking for both of my possible roots. So x equals 2 or x equals negative 2 are my two x-intercepts. They're my solutions. They're where my graph crosses the x-axis. They are the solutions to my equation. So we can also get those by using the method of factoring. When I factor, I have to remember to set my equation equal to 0 before I begin. So for example, if this was my problem, x squared minus 9x plus 16 equals negative 2, I would need to add 2 to both sides first. I get x squared minus 9x plus 18 equals 0. Now I could use the method of factoring if this was a factorable problem, and it is, because when I have my 18 on top and my negative 9 on the bottom, I get negative 6 and negative 3 as my side numbers. And this was an easy peasy type of problem because my A is 1. I don't have to take it by factor by grouping. I could just use my answers from my parentheses as my side numbers. Now, I'm not finished. The product of x minus 6 times x minus 3 is 0. So either x minus 6 equals 0 or x minus 3 equals 0. Solving that, adding 6 to both sides, I get x equals 6, and adding 3 to both sides, I get x equals 3. Those are my two x-intercepts. That's where my graph crosses the x-axis. Those are my solutions. Those are my two roots. 2 other methods that you learned last year were completing the square and quadratic formula. So let's discuss completing the square. There are 4 steps to completing the square. Step 1 is the setup step. This is when you get everything in order to complete the square. So I'm going to move my constant to the other side. I am also going to leave a space to complete the square. So I'm going to move my 9 over by subtracting 9 from both sides. I get x squared minus 8x, leave a space, equals -9, leave a space. So my step 2 is to complete the square. Step 2 is where I complete the square. And you might remember that as when I take my b term, I divide by 2 and I square it. So in this case, my b term is -8. I'm going to divide by 2 and square it. That's -4 squared, that's 16. 16 is the number that completes my square. So I put plus 16 with my trinomial, and now x squared minus 8x plus 16 is a perfect square trinomial. I also must add 16 to the other side, because what we do to one side of my equation, I have to do to the other side of my equation. So now my step 3, now that I've done that, I'm able to factor. So now I'm going to factor this perfect square trinomial. It perfectly factors into a binomial squared. What's that binomial? Take the square root of the first term, x, take the square root of the third term, 4, and keep the sign in the middle. X minus 4, it's also the same number in the middle step of completing the square. So x minus 4 squared is my binomial squared that's equal to my trinomial, x squared minus 8x plus 16. And on the right side, -9 plus 16 gives me a 7. So now, just like up above on the right, I can solve this by taking the square root of both sides. When I take the square root of the left side, this blue square root symbol and the green exponent of 2 cancel, and I just get x minus 4. And on the right side, I get plus or minus the square root of 7. So you're not done yet. You haven't solved for x. So now I'm going to add 4 to both sides. And I always tell my students, just drop that number in front of the square root symbol. So now I have x equals 4 plus or minus the square root of 7. This is 2 answers. This is 4 plus the square root of 7, and it's 4 minus the square root of 7. And you can leave this in decimal form or in this form, which we call exact form. The decimal form would be from our calculators, and it's called the approximate answer. So the fourth and final method that we're going to be reviewing this year is the quadratic formula. When I do the quadratic formula, I also must have my equation equal to 0 before I begin. So in this equation, I would subtract 3 from both sides and get x squared minus 8x plus 5 equals 0. Now, to do the quadratic formula, you might remember that it's x equals -b plus or minus b squared minus 4ac all over 2a. So in my problem, remember that the standard form is ax squared plus bx plus c. So in my problem, my a is 1, that's the coefficient of my x squared, my b is -8, and my c is 5. So let's go ahead and plug these numbers into my quadratic formula. So I get x equals -8, which is a positive 8, plus or minus -8 squared, which is 64, minus 4 times a times c, which is going to be 20, all over 2 times a, which is going to be 2. So I have 8 plus or minus the square root of 64 minus 20, all over 2. This is equal to 8 plus or minus the square root of 44, all over 2. So I can leave my answer in 2 different forms. One is called the exact answer, and one is called an approximate answer because I use my calculator. I've run out of room, so I'm going to move up here with my exact answer. So again, I have 8 plus or minus the square root of 44. The square root of 44 could be thought of as 4 times 11, and the square root of 4 is 2, so I'm going to bring that 2 on the outside, and that 11 is left on the inside. And now I see that I can cancel a factor of 2 from both of my terms in the numerator. If you have difficulty with this, we talked a little bit about this in the classroom. Just when you come back, come see me during office hours. If simplifying that to 4 plus or minus the square root of 11 is difficult, we'll go over the algebra. Or I could use my calculator. I can do 8 plus the square root of 44 and divide by 2, and 8 minus the square root of 44 and divide by 2, and I get x equals 0.68 or x equals 7.3. These are my approximate answers because they are my decimal answers. There's a time and place for leaving my answer in both methods. And again, if you have any trouble getting these answers simplified on your calculator for the decimals, come to office hours and I'll help you with those. So let's take a look at a couple problems on this page. I would first like to look at E at the top. So all the problems at the top of this page are using the method of taking the square root of both sides. That was my top right box on the previous page. So I need to isolate my x squared. I'm going to begin by subtracting 6 from both sides. I get negative 1/3 x squared equals negative 26. Now I need to multiply both sides by the reciprocal of 1/3, and it's a negative, so I'm going to make it a negative reciprocal, which would be 3/1. I'm going to multiply both sides by that. My 1s, my 3s, my negatives, everything cancels when I multiply by the reciprocal, and I get x squared equals positive 78. So now I'm going to take the square root of both sides. And again, writing with my Apple Pencil, I ran out of room, so I'm going to just move over to the side here. And so my final answer on the left side, my square root cancels my squared, and I get x equals plus or minus the square root of 78. And if I take the square root of 78 on my calculator, I get x equals plus or minus 8.83. So my graph crosses the x-axis a little after 8 and a little after negative 8 would be my two x-intercepts. Again, I have my exact answer and I have my approximate answer, and there's a time and place for both of those. So let's take a look at factoring by looking at 2b. This is unlike the example on page 7. This is a different problem. It's not a trinomial. This is a Gcf factoring problem. I have an x squared plus 16x, so I'm actually going to factor out an x from both of these terms, and I get x plus 16 equals 0. So now I can still solve by factoring. I still have a product. X times x plus 16 is 0. So still either x equals 0 or x plus 16 equals 0. So this is already solved. X is 0. And I would subtract 16 from both sides and get x also equals negative 16. Again, that means that negative 16 and 0 are the two places where my parabola crosses the x-axis. On page 9, let's take a look at completing the square problem. Let's take a look at E. So remember, my A must be 1. So in this problem, my A is already 1, so I'm ready to go. I know that my first step is to move the constant and leave a space. So when I do step 1, I have x squared minus 4x, leave a space. I'm going to subtract 1 from both sides to move it, so equals negative 1 and leave a space. So now I'm ready for step 2. Step 2 was to complete the square. So I'm going to take my b term and divide by 2 and square it. I get negative 2 squared, I get 4. So plus 4 is the number that completes my square. It makes a perfect square trinomial. And if I do that to the left, I'm going to also do it to the right. So now, step 3 is where I factor. A perfect square trinomial perfectly factors into a binomial squared. That's the whole purpose of this method. So square root of the first is x, square root of the third is 2, and sign from the middle is a negative. I notice that's also what I see up above in my middle step of completing the square. I see a negative 2 equals positive 3. So this is solvable. I can take the square root of both sides, so let's do that. I get x minus 2 equals plus or minus the square root of 3. So I'm now going to solve for x. I'm going to add 2 to both sides to get the negative 2 to cancel. When I do that, I just slide that in front of my plus minus, and I get x equals 2 plus minus the square root of 3. You can also leave this in decimal form if you wanted to get those two answers, 2 plus the square root of 3 and 2 minus the square root of 3 from your calculator. Thank you.